So we have a graph here, a network, and P2QS is a walk from P to S. PQTS. Yeah, you can go walk any way you want to get there, so the answer is true. Okay, PQTS is a path from P to S. Well, you're only allowed to use each shade once, each line once. PQTS, yep, it's also a path, so that's true. Walk, you're allowed to reuse each line if you want. You can just walk indefinitely if you want. You can go P to Q, then back again. But on a path, you're not allowed to do that. Okay, it's PQTURS is a path of length 6 from P to S. Let's find out. So P to Q, Q to T, T to U, U to R, and R to S. And we use each edge only once, which means it is a path. And how many sides did we use? 1, 2, 3. 1, 2, 3, 4, 5. Yeah, did I miss something? P to Q is 1, Q to T is 2, T to U is 3, U to R is 4, R to S is 5. So we use 5 sides, so I might disagree with that unless we're. Yeah, it's false. It's a path of length 5. It's not length 6, it's length 5. That's false. Okay, next one. Is this one a path? I don't think it can be because it visits the same letter twice. We'll find out for sure though. If it uses the same line twice, it's not a path. So here we go. We're going to do P to Q first. We're going to do Q to R, R to T, T to U, U to R. I think we're stuck here now. And we're doing R to T again, so that means it can't be a path, so that's false. R visits it twice. False. R to T, sorry. R to T used twice. Edge RT used twice. It's edge RT used twice. Okay. Is PQRSTUP a cycle? So it has to have a start and end point, and it's only allowed to use each part once. So let's figure this out. Okay, so we have P to Q, yep. Q to R, yep. R to T, yes. T to U, yes. R to T, sorry, T to U. No, T U. T U R. Yep. R to T. T to U. Oh, sorry, I'm looking at the wrong one. I must be looking at question 5. Question 5. P to Q. Q to R. R to S. S to T. T to U. And U to P. Yeah, that's a cycle. Each edge is only used twice, and the start and end point are the same. True. Now, next one. SRQ, TRS is a cycle. Okay, let's find out. So cycle SRQ, T to R, R to S. It reuses the same side twice, so I'll say false. Vertex R visited twice. Vertex R visited twice. Okay. And the last one is, well, we can see right, is SRU PQTS a cycle? So we're going for SRU PQTS. We're going to see if this is a cycle or not. So we're going to go up and we're going to put in our new cycle. See what happens. Okay. S to R, R to U, U to P, P to Q, Q to T, T to S. This is a cycle because it starts and ends in the same place and doesn't visit any of the other vertexes twice. So it's true. Okay. Goal is start at A, end up at X, and try and do it as many different ways as I can. But the first way is going to be the most direct way. It's going to be A, B, X, W. Okay, so that's an easy one to get out of the way. A, B, X, W. So A, B, X, W. Next one I can go is A, D, C, B, X, W. A, D, C, B, X, W. Okay, then I can sort of do a bit of a roundabout here. I can go X, Y, Z, W. So I can do A, D, C, B, X, Y, Z, W. And then we had that one from earlier in the question where I went from A to X, but then I'm going A, Y, and then I'm going to go this way. So I'm going to do A, B, B, X, Y, Z, W. Is it possible to find a cycle which contains A and Y? The answer would be no, because once I get to Y, there's no way I can get out again without using the same side. So no matter what happens, I'm going to have to go from A to B, whether it's this route or this route. So once I go in this direction, A is now cornered off and can't be accessed unless I take one of the other routes. So yeah, if I took A to B on the way over, that's okay. It's the linker, B to X. Once I travel from one square to the other using B to X, the only way back across is via B to X, which means I'm going to be using the same side twice, which means it's not possible. No, not possible. Now, is this graph connected or disconnected? Now, what is a connected graph? A connected graph is where any two vertices are linked together. So, is this graph connected or disconnected? Well, it's disconnected because it can't link anything from the first triangle into the second triangle. So, we'll go for disconnected. Because there's no way of linking B to E or A to E. Write down a cycle which begins and ends at B. Well, BAC. BAC. B. Okay. Is the walk FED a path? Path means one direction, using each one twice. Yes, it is, because you only use each edge once. Is the walk VED a cycle? No, as it doesn't finish at the same point. It doesn't start and finish at the same point. Okay,